Also, you can choose what is your design method. We are using AISC 15th edition LRFD. This is the newest version of standard AISCE. So I will start first with new. New will open a new window, can tell you what is the type of your connection. Is your connection is beam to beam splice for shear only? Beam to column? Beam to girder? Column splice, column to column? So I think our beam or our connection will be beam splice under shear only. So if I choose this connection, which is this one, okay, here is the connection. Beam to beam splice, plate splice connection for shear only. Can you want this one? Connection category. You can choose different type of bolted. If you select here, welded connection, what happened? It's welding. Becomes welded connection at this location, and we have another weld connection at the other location. That's right? Okay, I will keep it bolted connection. Also, you can choose welded bolted or bolted welded. Like this. One side is welded and the other side is bolted. It's up to you. And what is the availability in your side? Anyway, the second one, what is the value of your shear force? So go ahead for your shear force diagram and select what is the value. Maybe we can keep it 60, keep. Then, what is the left beam cross section? Maybe your cross section not W16 times 36. Go ahead and select what is the shape of your cross section. So maybe it's 18 times 50. Okay, so it becomes bigger. The second one also 18 times 50. So for the second beam, it choose 18 times 50. That's fine. Then open this arrow to choose what is the properties of your plate section. I'm talking right now about this plate. What is the material? What is the thickness? Maybe your thickness 0.5 inch. What is the width? It's 6 point something. So we can choose it 10 to see what will happen. What happened? Wider. Becomes wider. And also, what is the depth? The total depth. What is the number of plate? Is it single or double? What do you mean by single or double?
One on each side?
Yes. For the other side, nothing. If you choose it's double, we have another one on the other side. You got it? So we have many options. You can try in between until you reach something called what? Base.
Yeah.
Until now, your connection is failed. Until now, under the effect of your shear force equals 60. Let's try another value. 30. Fail. 10. Still fail. Something wrong in your connection. Maybe not related to your load. Another thing I will show you. So keep it 60 and let's see. Okay. Maybe number of blades, we figured it out. Hole type, what is the type of your hole for bolts? Anyway. For we did. For left beam web bolts, the left. As you see, if you are choosing something here, the color of your element will be in gray color. So we are talking right now on the left bolts. You can choose what is the type. We have many different type of bolts. You can choose what is the diameter of your bolt, 3/4 or 7/8 or 1 inch, 1 inch and 1/8. If you choose anything, you see the size of your bolt change. How many rows do you have? 1 row, I can change it to 2 rows. I can change 3 rows. As you like. I can, how many bolts per row? 1, 2, 3, 4 bolts per each row. We can change it to 6. Doesn't make sense because you have a bolt embedded in your flange. So, and also we have limited spacing between bolts and limited spacing between the last bolt and the edge of your blade. So we need to, not any number not be accepted. Anyway, longitudinal spacing. What are the longitudinal spacing between each bolt and transverse spacing? If you choose right beam web, we are talking about bolts on the right side. You can change what you want, like how many bolts or how many rows, how many bolts per row, and everything. Blade vertical position. You can choose, change this one, see what will happen. Where is the blade exactly? What is the distance between this blade and the top flange? This distance right now, the vertical distance, 3 inch. If you choose it 5 inch, it will move down. If you choose it 1.5, it will move up. So we can make it at the center. At the end, you can watch if your connection is still safe or unsafe. Right now it's unsafe. If you would like to see what is the problem, go ahead and open report. Can tell you everything about calculations. Everything based. And anybody here can tell me what is the meaning of this number?
Safety plan?
Not safety. We have R ultimate and phi Rn. Here is your design philosophy. All the time we need this value smaller than or equal. That means if you divide R ultimate by phi Rn must be smaller than or equal 1. That's right? Each number smaller than 1, base. You are safe. Because your Rn, R ultimate, divided by phi Rn will be smaller than or equal 1. But for the first geometry restriction, that means maybe your cross section is not non-compact section. You have cylinder cross section because your cross section is too large. So we have issue with the geometry restriction of your cross section. But everything for bleed shear yield, for left beam shear yield, for everything for related to stresses and the design, we are safe. You got it? And also, if you would like to see more details about your calculation, you can check here. You can open this one by click and can tell you what is the required strength, what is the available strength, what is the value of phi, and what is the ratio between available and required. You got it? This one or this software is very important Because this type of connection is more complicated. We have many different things we need to figure it out. Number of bolts in your left, number of bolts in your right, and what is the size of your blade. So we need to make many trials. Many trials with health calculation, you need more time. But with software, it's just trial, and you can see what will happen if you change this one or increase this one or decrease this one. This is the first type of connection, which called shear connection, beam to beam shear connection. We have limited length of your beams, so we need sometimes to make splice, to make connection between two bars to construct your total length of beam. What will happen if this beam will support shear and moment? What do you think? Your shear in beam, in steel beam, your shear mainly supported by web. So if you would like your connection to support shear only, I need to connect web and web. If you are talking about moment, most of the moment is supported by flange and flange. So if you would like to make this connection to support moment, I think I need to connect this flange by this flange. Let's see. Second connection, which called beam to beam moment blade splice connection. Yes. At this time, we can define what is the shear force, what is the bending moment. Axial force is nothing. Most of the time, we don't have axial for beams. So we can figure out what is the value of moment, kept foot, what is the value of your shear. Also, for this one, between your web and your web, we have blade to transfer shear. Between your flange and your flange, we have blade to transfer moment. This type of connection is more complicated to figure out how many bolts I need at the top, how many bolts at the bottom, how many bolts for shear. So once you select your cross section, your type of connection, you can define what you want. Let's see. For your software, if you would like to add another type of connection for this project, you can say new. Now we have, go down, beam splice but to support moment. The first one, beam splice only to support shear. The second one, beam splice only to support moment. So choose this one. We have different type. We will select the first one, for example. Here you go. Remember, the first connection is still in your project. You can select in between here. The first one is still there. The second one, the new one, is here. So I can design maybe 10 or 20 connections at the same file or at the same project. Anyway, so your connection right now will support moment and shear. Still fail. We have something wrong. Maybe if you would like to see what's the wrong, go ahead for report. And everything is base except blade shear rupture, blade shear rupture. We have issue with the blade supporting shear. Fail with only 0.05. So almost. As you see, one more time, if this number smaller than 1, you are safe. More smaller than 1, you are more safe. Like this one, 0.47, more safe. Like this one, 0.91, perfect. Between 0.9 to 1 or 0.99 will be good. But if your number greatest than 1, you are unsafe because the required is 60. The required is 60, but the available strength is 65.
Exactly.
I'm sorry, this one. The required is 60, but the available is 57. So if you divide required strengths by the available strengths, your value will be greater than 1. Okay? So we can change something related to plate. Go back. We have something issue with this plate. So let's try. Where is the component? Here is a component. We have left beam, we have right beam, we have plate section. Let's try with the plate section. We can change thickness. Let's try 0.5. Still unsafe. Let's change the width.
8 inches.
Still unsafe. Maybe number of plate. Let's try double base. So if your cross section of your connection with only one plate, it's not bad. If you change, everything's the same, number of bolts, diameter of bolts, everything, but you change, we need 2 plates, double, you have base. Like this. So, go back to your report. What is the left beam shear rupture? Becomes 0.91. 0.91. You are fit. You got it? So, this software will be the perfect software you can choose because we have many factors in your connection, and if you would like to design with your hand, no way, because you have many factors you need to change. Maybe one your thickness, maybe how many plates do you have, how many bolts, so we need to assume and check, so we don't have time. Any question? The second one, or the third one, is beam to column connection. Yeah, if you have frame, you will need something like this.